welcome back to Learn Physics. In today's topic, we are going to continue with the previous year question paper, that is for class 10 students. Okay, so in last video we did till the 22nd question, and today we will continue with the 23rd one. If the image formed by a mirror for all positions of the object placed in front of it is always diminished, erect and virtual, state the type of mirror and also draw a ray diagram to justify your answer. Write one use such mirrors are put to and why. Okay. So, image formed by a mirror for all the positions of the object placed in front of it is always diminished, erect and virtual. So, a mirror which will give only virtual images, those kind of mirrors are called as, yes, it is a convex mirror. So, 23rd one, first one, convex mirrors will always give virtual and erect image. Okay, virtual and erect as well as diminished also. Okay, state the type of mirror and also draw a ray diagram to justify your answer. So convex mirror, many times we draw this diagram. This is a convex mirror, principal axis. If I am taking this is here, this side only we will be getting F and straight line, this will be the position of C, object is here, then we will be getting a parallel rays which are going parallel to each other. It will be reflected as from the principal focus. Okay, the ray which is about to fall through the center of curvature will go undeviated, retrace its path. Okay, it will be retracing its path. So both are meeting at this position. So it is diverging mirror. Okay, so it's a diverging mirror. This is the position of object and this is the position of image. Okay, so this is the ray diagram. So it is a diminished, virtual and erect image. Okay, so next is also write one use such mirrors are put to and why. So what are the uses of a convex mirror? It's used as a rear view mirror. It is used as a rear view mirror. So large distance, the object which are at large distance also will be viewed as very close by and wide range of view. It is observed through this convex mirrors. It is erect, so we can see it properly. Erect images, isn't it? So these are the uses of this convex mirrors which are used as a rear view mirror. Next is define the radius of curvature of a spherical mirror. What is the radius of curvature? Distance between the center of curvature and pole. Distance between center of curvature and pole of a mirror is called a radius of curvature. Radius of curvature is the distance between the center of curvature and pole. Distance between the center of curvature and pole is called a radius of curvature. Find the nature and focal length of a spherical mirror whose radius of curvature is 24 cm. Radius of curvature is given as plus 24 cm. We should find out the focal length. What is the relation connecting R and F? R equals 2 into F. Therefore, F is equal to plus 12 centimeter. Since it is positive, focal length is positive, we can say it is a convex mirror. For a convex mirror, focal length will always be a positive quantity. Okay, so the next one, 24th question. A student suffering from myopia is not able to see distinctly the objects placed beyond 5 meters. List 2 possible reasons due to which this defect of vision may have arisen. With the help of any diagrams, explain why the student is unable to see distinctly the objects placed beyond 5 meters from his eyes. The type of corrective lens used to restore proper vision and how this defect is corrected by the use of this lens. This is A part of the 24th question. Okay, so student is suffering from myopia. What is myopia? Myopia is nearsightedness. That means the student can view only the nearby object. That is myopia. So list two possible reasons of this defect. What are the reasons? Extensive curvature of the eyeball, isn't it? Eyeball will be extensive curvature of the eye lens and elongation of the eyeball. So what are the reasons? Elongation of eyeball and excessive curvature of eye lens. Okay, these are the two. How we will draw the diagram for that? The rays which are coming from far away distance, far away points means they can't see the far objects clearly. So from the far object, if the light ray is coming and incidenting on the eye lens, what will happen? Yes, it will be forming an image in front of the retina. Image will be forming in front of the retina. Actually, the image should form on the retina. So how we can correct that? So we can correct it that using a we can correct this using a concave lens. Okay, so here the rays which are coming like this, so it will diverge and go, and that will be forming an image on the retina. Okay, so this is for the nearsightedness and far-sightedness. Both the diagrams very important. Okay, those diagrams you should learn. Okay, for myopia we will be using a concave lens. Why student is unable to see distinctly the objects placed beyond 5 meters from his eye? Because if the light ray is coming from very far away distance and image will be forming in front of the retina. That is the reason the student can't view the objects which is coming, the light ray which is coming from far away distance. So the image is forming in front of the retina. The type of corrective lens used to restore proper vision and how this defect is corrected by the use of this lens. So what will happen? See, we will be using a diverging mirror lens. That is, we will be using a concave lens. And if you are using a concave lens, then the rays which are coming through from the far away distance will be forming an image at the on the retina, will help to diverge the image from the, so the rays which are coming from this one will be falling on it and it will help to diverge the rays. So the diverged rays will be coming and falling on the retina. Okay, clear? If in this case the numerical value of focal length of a corrective lens is 5 meter, find the power of a lens as per the new Cartesian sign convention. So this is a corrective lens. For this corrective lens, if the focal length is given as 5 meter, since it is a concave lens, it will be negative. Focal length will be negative. P equals 1 by F, so we can write it as 1 by 5, so it is minus 0.2 diopter. Okay, so this is the second part of this 24th question. Now we are moving to section B, and in that the physics question is coming from question number 30. From 30th question onwards, physics questions are coming. Okay. So here 30th question, study the given ray diagrams and select the correct statement from the following. So here ray diagrams are given. So 30th question, see 1x, and this is the position of screen, and this is 20 centimeter, and the rays which are falling like this, So everything is meeting at this point here. Okay. So that is one diagram, and the second one diagram here. This is Y, and this is screen, and this distance is 25 centimeter, and the rays which are coming and incidenting like this Okay, so this is the ray diagram. Now I'll read out the options, and so you just check. Device X as a concave mirror and device Y as a convex lens whose focal lengths are 20 centimeter and 25 centimeter. So first we should identify which lens is X and which lens or mirror is X and Y. So first we will find out that. Then while reading out this, it will be easy to identify for you. Okay, so X, this is the rays are coming the other side, isn't it? So this will be lens. Now we should identify whether it is a convex lens or concave lens. So here here it is converging to a point. It's not diverging. Rays are not moving, incidenting and going back in the same side means it will be diverging. Now it is converging lens. So what is converging lens? Other name converging lens also you can write, or the other name is convex lens. Okay, distant object light rays are falling and incidenting over here. Then what will be the distance between X and screen? Lens and screen will be focal length as 20 centimeter. Okay, here from the distant object rays are coming here. So focal length is 25 centimeter. So light ray is incidenting and reflecting back. So it will be a mirror. So with which type of mirror it is? Convex or concave? So it is converging mirror. Converging mirror means it will be a concave mirror. Okay, now I will find out which is the correct answer. First one I read out already. Then it was a concave mirror and Y is a convex lens they are telling. So it is wrong. Second one, device X is a convex lens. Correct. And Y is a concave mirror. That also correct. Whose focal length is 10 centimeter and 25 centimeter. So here 10 centimeter is wrong. Here it is 20 centimeter. So that is wrong. Next is device X is a concave lens. Device X is not a concave lens. So that also wrong. Then D. Device X is a convex lens and Y is a concave mirror whose focal lengths are 20 centimeter and 25 centimeter respectively. So here the answer is D. Okay, last option is correct. Next is 31st question. A student obtains a blurred image of a distant object on a screen using a convex lens. Blurred image. Okay, so from distant object we are getting a blurred image on the screen. To obtain a distinct image on the screen, he should move the lens away from the screen, towards the screen, to a position very far from the screen, either towards or away from the screen, depending on the position of object. So practically what we will do, we are getting a blurred image, means we will move forward or backward and see at which position we are getting the correct image. So here the answer will be D, either towards or away from the screen depending upon the position of object. Okay, so the next one is 32nd question. A student very cautiously traces the path of a ray through a glass slab for different values of angle I. He then measures corresponding angle R, angle of refraction, and angle of emergence for every value of angle of incidence. On analyzing this, here the values are given. I'll write out here. Okay, I greater than R greater than E. I equals E greater than R. I less than R less than E. I equals E less than R. So what will be the answer? See, angle of incidence and angle of emergence will be equal. Why? Because of that only we are getting lateral dispersion, isn't it? In a glass slab only it is given. So in a glass slab we will be getting an image like this. So angle of incidence and angle of emergence are same. That is the reason we are getting parallel rays and lateral dispersion. The reason also we are telling for this reason, since I is equal to E. So I is equal to E. These two are correct. Then whether E is greater than R or less than R. See R. Where is it? See, this is R. This is the position of R. So R is less than E. Isn't it? Because the light ray is after refraction rarer to denser medium, moving towards the normal. When it is moving towards the normal, the angle of refraction will be less than the angle of emergence. So the correct answer is B. I is equal to E and which is greater than R. So this condition you can by heart and keep, because I, in the case of a glass slab, I is equal to E. Angle of incidence is equal to angle of emergence, which is greater than the angle of refraction. Okay. So the next one. So this is the diagram. In this diagram, the angle of incidence, angle of emergence and angle of deviation respectively have been represented by angle of incident. Incident ray where it is falling. So usually we will draw the incident ray this side, isn't it? But here in this diagram you just see the incident, the angle, the light ray is coming in this side. Isn't it? So what is the angle? P is angle of incidence. That one you should remember. So while you are observing the diagram, observe it carefully. Okay? So P and angle of emergence. What is emergence? Y. And what is angle of deviation? Z. Z is the angle of deviation. So here in this options are given. The option is P, Y, Z, that is C. Option C is the correct one. Okay, so the next one more question is there, that is 36th question. A student focuses the image of a candle flame placed at about 2 meters from a convex lens of focal length 10 centimeter on a screen. Okay, so focuses the image of a candle flame placed at about 2 meters from a convex lens of focal length 10 centimeter on a screen. After that, he moves gradually the flame towards the lens and each time focuses its image on the screen. So now it is at a distance to 2 meters, and when he is trying to gradually moving towards the lens and each time focuses the image on the screen. Okay, so what happens to the size of the image of the flame formed on the screen in the case of a convex lens? So convex lens, when the object is coming closer, what will happen? It is increasing. Image size will be increasing. As before, lens means at 2f, before so b at 2f or beyond 2f, between f and 2f, that will be studied. So how the image will be? Image distance, you can think about the image distance or size of the image, you can think. So it will be increasing, isn't it? So the lens, if the object is moving towards the lens, till f, the image size will be increasing and we will be getting a real inverted image. Okay. What difference is seen in the intensity of the image of the flame on the screen? What happens to the brightness of the image? Brightness of the image will be decreasing as it is coming closer to the lens. Okay, as the object is coming closer, the brightness will be decreasing. What is seen on the screen when the flame is very close to the lens? If it is very close to the lens, what will be happening? We will be getting virtual images. No images will be forming on the screen. We can't catch the image on the screen if it is very close by. F and O. If the object is between F and O, we can't see any clear image because that's not. Image formed will be a virtual image and we can't catch the image on the screen. Okay, clear? Understood? That is 36th question. So this is question 2017 question paper is over. The physics part. The rest of the parts I think you are doing it properly. And if you have any doubt in this questions, please you can message it through the comment box. And if you like the channel, please don't forget to subscribe. Thank you for watching. Bye.